So let's go back. I'm going to go into predicting the range here. And let me grab that data. So I'll pull this over and say copy. And when I copy this, I'm going to go back into the generator. Once I go back into the generator, I am just going to paste. And voila, there's placement. There's the pasting that's taking place. And if you look at increments, we are incrementing. I don't know if you guys remember, but we talked about this. So we're incrementing everything in here. And we go to the equation of the line. This is just an extension of what we've done previously. So I don't know if I can move this formula. I don't think that I can move this formula on the iPad. If it's one thing that I don't like, that I can't really manipulate equations really well on the iPad. But we generated an equation at the top here, all right? So if X, which is on the X-axis, that's our angle in degrees. If that happens to be 0, look at what our value is going to be in meters. It's going to be 0.3919, and that's approximately 4. So as we add our angles in here, you see that this equation is going to increase and increase and increase and increase. This is what we call a linear equation. The R squared value here, it's just basically talking about, or it's saying, this is how close we got to the center of each point. The closer this value is to 1, the better off we are. That's really what we're saying there. I want to show you something. This is called linear regression. It's also a least squares fit and all of that other good stuff. I want to show you a calculator. Let me see if this thing is still available here. Okay, here's a calculator that I built earlier today, and it's called a nonlinear regression calculator, where basically we're given values in time here, and we're given values in feet here. I should say seconds here, and time here for the y, and we are to come up with an equation. And that equation is going to look like y equals to mx plus, y is equal to mx squared plus b. So it's similar, but it's non-linear. And we just generate it. And so if we know the value for time, we take it, we square it. If we know the value for the y, we take the time squared times y, and then we do something here, and we come up with some values. If you look here, I generated some calculations or some equations here, and you come up with some values. And with these two values, you can have an equation that represents this data set. And if I go to quadratic regression here, you'll see that here is the plot of those values. So if I go back to quadratic regression, I'm looking at time and I'm looking at feet. So I put those values are here. This is the way the graph looks. And then when I do a best fit line here, I get this equation. So you'll see that we have 8.83x squared plus 0.1401x plus this value here. And our R value is 1. So it's going through the center of each one of these. If I go back to my least squares fit, you'll see that M is 8.882. If you go here, we go back to our quadratic, this is our M. This 8.83, that's our M. And this is something extra, and then this is our B. This is our, where we're crossing the Y here. So I just thought I'd share that with you guys. That's the end of this. You make sure that you submit this, okay? If we go back to predicting the range, you don't need to submit the thing that I just talked about, but you do need to submit this work. So share this file with send link, copy link, and make sure you put it into the Moodle site, all right?